Okay, before I show you the graph here, what we're being asked in this problem is the relative maximum, the relative minimum, increasing, decreasing, and constant. Now, when I look over here at the graph, they've provided me with a parabola. There are two things that I've done. I've made the arrows point down. There weren't arrows here, but a parabola continues, as you know, but those arrows are important, okay? Especially for domain and range, but increasing and decreasing as well. So you need to know they're there. The next thing I did is this. They told me that the vertex was negative 4.5 comma 6.25. But on course compass, it almost looks like there's a tiny hole there, and there's really not, okay? What I want to point out to you in math in general, and to my students in particular, in case you're not one, if you're one of mine, you've heard this in class, but if you're not one of mine, that is not a hole. If I want that to be a hole, I'm going to make it a big old circle. That vertex, that is the vertex of this parabola, and that's a very important point. Okay, because this parabola opens down, that means that this parabola is going to have a relative maximum value. And remember, a maximum value is not the x value. A maximum value is always output. So the y value here, the highest y value, is 6.25. So the relative maximum is 6.25. Okay? Don't put the whole ordered pair. The ordered pair is where the maximum occurs, but the relative maximum is the y value. Relative minimum, or minima, there could be more than one. This graph drops forever. Okay? There's never a valley. That's a good way to look at it. A relative maximum occurs at a hill. A relative minimum occurs at a valley. There are no valleys here. What I would put for relative minimum is I would keep it real simple and just say none. Okay? Now, some of you that are watching this that I'm not your instructor, some of your instructors might teach you to write negative infinity. Again, I would discuss that with them. My personal preference, if you're one of my college algebra students, is that you write none. Is there a relative minimum? No, there's none. That's the answer I'd prefer to see. Okay, increasing, decreasing, constant. Well, we can make very quick work of the constant. This graph is never level. It's never horizontal. So where is it constant? Never. Okay? It's never constant. Don't put something silly like empty set. You're not solving an equation here. You are asked, where is the graph constant? What's your answer? Never. Okay? Now, increasing and decreasing is always in terms of x. Okay, so I'm going to draw this little line right here. I'm going to dot it in, my vertical line, and that's the line x equals negative 4.5. We can see that from the vertex they gave us. Okay? This part of the curve is obviously increasing because as we go from left to right, the y value is getting bigger, and this part of the curve is decreasing. But remember, to answer increasing and decreasing, you always do it in terms of x. So we're scanning from left to right. When I come from the left, I'm coming from negative infinity, so I'm scanning from negative infinity until the graph reaches the x value of negative 4.5, and that is where the graph is increasing. So from negative infinity, comma, to negative 4.5 with a paren. Please remember, increasing, decreasing, and constant never take brackets. It's always parens. Decreasing, well, my x value here is a negative 4.5, and as I walk on the x-axis toward infinity, right, that's where I'm walking toward, that's where my graph is dropping, okay? So remember, when I'm answering decreasing, I know the graph is going down, but I'm walking along the x-axis. That's why I'm going toward infinity, okay? The x values get bigger. So the answer for that would be from negative 4.5 to infinity. and we're done.